The universe is an isolated system. You're probably asking yourself, why is this significant? Also, you're probably asking yourself, how is this true? And above all, how does this define immortality? Well, let's first of all look at a definition of what an isolated system is, in case you don't know. YourDictionary.com defines an isolated system as one which does not interact with its surroundings. That is, energy and mass stay constant. There are two actual descriptions of an isolated system. This is using Wikipedia, a dubious source, but it was probably where I could best find an explanation for this. First is in a physical system in which such a system is far removed from other systems. That is, that it does not interact with them. The second description is in thermodynamic systems, which is where we're going to be focused on mostly in today's talk. This is where such a system is enclosed by rigid and immovable walls through which neither mass nor energy may pass. We can contrast the isolated system with both a closed and open system. In a closed system, matter is not exchanged, which is the same as an isolated system. However, the difference is that energy is exchanged. Now, in an open system, both energy and matter is exchanged. You might think of an open system as this cup here. It's surrounded on all sides, but it's open here, so matter, which in this case would be steam. If I put a hot beverage, you have liquid, it would dissipate into the air. Anyway, that is an open system. Now, let's assume I put a lid on it. Well, what does that become? It becomes a closed system. Why? Because matter will not escape. Energy, matter may escape, but as previously said, the matter will not exchange, but the energy will. Which, for example, heat. If I put hot beverage into a closed container, I can feel that container. I can feel heat. That makes that a closed system. An isolated system is one that which is totally enclosed, and we cannot get heat or anything coming out. You touch a, let's say you're able to create a perfect container that perfectly contains a system, in this case hot water. You put your hand on it, you won't feel anything. Now, there is no such thing as a perfectly isolated system. So according to classic theories, there are ones that approach that. You could put nuclear radiation, a radioactive substance, in a lead container and bury it deep underground. It probably won't seep out of the ground for thousands of years, which is something you want to have in the case of a radioactive substance. You don't want that to seep into the ground or anywhere else. But the existence of, for example, a Carnot engine, that doesn't exist. That's just a model. That's an idealistic model of a unit that does not exchange heat, energy, or matter. Now, in an open system, both energy and matter are exchanged. I think I already touched on that. In an isolated system, the conservation law exists, the law of conservation. Now, to get onto what that law of conservation is all about, we're going to see that all laws of conservation of inner momentum are observed. As well as the conservation of angular momentum. Now, these are all laws of physics. The conservation of electric charge, the conservation of mass, parity, lepton numbers, baryon numbers, strangeness and hypercharge, and many others will apply. I'm not going to get into all those definitions because we're not going to go down that rabbit hole. If you want to look them up just remember Google is your friend, or just use any other search engine as your friend as well. But we'll just continue. We'll digress here. However, it will be the conservation of mass and energy where we will be primarily focused in today's lecture. This is kind of where the rubber hits the road here. The law of conservation of mass states that in any closed system or isolated system, that being the previously noted, a system closed to matter and energy, the mass will remain constant. In an isolated system, mass and energy remain constant, as previously stated. It could be altered through any thermodynamic process, such as a chemical reaction. For all practical purposes, conservation of mass and energy only applies in classical or Newtonian mechanics, which, if you don't understand what I'm saying, this is really the mechanics before we came up with all these 20th century concepts. Einstein's theory of relativity, some other theoretical ideas such as quantum mechanics, and so on. This is not regarded as valid in the case of, well, as I said, quantum mechanics and special relativity. In these cases, principles of mass energy equivalence are modified to accommodate. So people trying to work on these models have had modifications and able to try to make the model of an isolated system fit practical realities. This accommodation states that energy and mass form one conserved quantity. In nuclear chain reactions and particle annihilation, both mass and energy must be observed, or must be conserved, I should say, and not mass only. Mass and energy are not entirely conserved when general relativity is taken into consideration, as in the case of strong gravitational fields. Now, we're going to move on to one of our favorite scientists here, Albert Einstein, whose ideas have always been respected. According to Einstein, this pertains to his famous equation E equals mc squared. We're going to talk about E equals mc squared and just what it means. It's a simple equation, of course, but for those who don't know, E is for energy, m is for mass, and c is for the speed of light. Now, this refers to energy of a body at rest. In the we're going to go to historically. In the early 20th century, it was found that the light had a speed. And I'm just going to hold up this book. If you want a really good explanation of what is relativity, read this book. Comes right from the horse's mouth, so to speak. And it's a little bit, it's done in a way that is not terribly complex. You don't have to have a PhD in physics to understand this book. There's some concepts that are a little bit, that may challenge your line of thinking though. Anyway, what Einstein was explaining here is that light will travel in a moving object regardless on the speed or angle of the object. Let's assume you're driving in a car. Now, when you're driving, you're seeing everything passing by you. You're seeing the street, you're seeing the sidewalks, you're seeing the houses. Now, the house will move a little bit slower than the sidewalk. Why? Because it's farther away. But you're going to keep going. Is that street moving towards you? No, you're moving towards the street. But you see, light will travel to you just as quickly from the from the fire hydrant that you passed to, let's say, a hill or a water tower way off in the distance. Light is going to travel at the exact same speed. And you may go faster. You might go directly into the line of that hill, but it's going to still travel to you just as fast as if you stood still. So this was a problem that Einstein worked on. Now, this would differ from being an automobile. Speed is a measure of space divided by time. Now, this is how E equals mc squared is derived. Again, it's a very simple equation. Einstein did not bore us with long theorems that would have taken volumes. No, he just had one simple equation. He said, this is it. See, in classical mechanics, now we're getting back to Newton and the rest of those fellows there. In classical mechanics, energy can be stored as gravity. But E equals mc squared states that energy can be stored as mass. This is an important consideration here. If you place a flashlight on a hypersensitive scale and turn it on, and we're talking about very minuscule degrees of mass here. There is a very small, and I mean minuscule, probably something beyond measure, but there's a small loss in mass as light is emitted. If you heat water, the mass will be gained. Again, this is something that probably is not measurable unless you have a hypersensitive scale. But if you put, let's say, to use SI units, a liter of water, and you heat it up to the boiling point, which in Celsius would be 100 degrees Celsius. It will heat up, it'll start boiling, but it will be at a higher mass than it was before. Now, here's another interesting concept. If you take two objects, I'm just going to use two pieces of putty, or like, let's say, silly putty. You know, the stuff you can buy at a toy store. I don't even know if they make the stuff anymore. Let's probably use something else like Play-Doh. Okay, that's another stuff kids play with these days. But you take two Play-Doh balls and you throw them together at a high velocity, and they stick together. Now, not only will the mass, what'll happen is you have, let's say your one silly putty is 1 kilogram, the other is 1 kilogram. You throw them together and they will stick together. Now they're going to be 2 kilograms, but the thing is, there will be kinetic energy involved. So it won't just be 2 kilograms we're talking about. The mass will actually increase because we're using kinetic energy to stick together these two balls of silly putty. So let's return to thermodynamics. I think we already covered relativity here, but there are 4 laws of thermodynamics. The first 2 were devised by physicist Sadi Carnot in 1824. As I previously mentioned, the Carnot engine. This was one of his ideas. You cannot go to Walmart, by the way, and look for a Carnot engine. They're going to look at you like, what is that? You might as well go there and ask for a perpetual motion machine. No, those do not exist. The U.S. Patent Office will absolutely reject a perpetual motion machine if you even suggest that you have an idea for one. I'm going to say no. This is out of the question. Anyway. Carnot devised the third theorem. This was we're going to talk about actually the 4 laws of thermodynamics. The first 2 were discovered by Sadi Carnot, as I previously said. Then the third was established by the German scientist, a rather interesting person. If you want to look at his biography, it's quite interesting. Walter Nernst, N-E-R-N-S-T, that's in 1920. He was actually a protege of Albert Einstein. Anyway, and then there is the zeroth law. This was originally, though it wasn't given that name until much later, this was a theorem formulated by Scottish physicist James Clerk Maxwell, who you probably already know if you know anything about physics. It's in 1871. He was a very scientifically minded person. He was a trained scientist, and he kind of took the ideas of another great scientist who was Faraday, Michael Faraday, and he kind of formulated a series of calculations based on Faraday's finding. Faraday, for all of his brilliance, was not really a mathematician, but Maxwell was. So he devised what is now known as Maxwell's equation. Anyway, I digress. Clerk Maxwell in 1871 came up with this law. Now I'm going to tell you what these 4 laws entail. They are as follows. The zeroth law states that if 2 systems were exact in thermal equilibrium, which is to say that there is no net flow of thermal energy between them when they are connected by a path permeable to heat with a third system, then they are in thermal equilibrium with each other. Now that's a lot to digest there, so let me give you another explanation here. The first law states that when energy passes in or out of a system, the system's internal energy changes and enable to accommodate according to the law of conservation of in accordance to the laws of conservation of energy. It is destroyed, or as tested by French physicist, a woman physicist, which was unusual in that day, Emile du Châtelet, who proclaimed that energy cannot be created or destroyed. this is a significant thing. Energy cannot be created or destroyed. Where have you heard that before? Well, that's in a nutshell. That's what the first law of thermodynamics tells us. The second law states that in the simplest terms, not all heat can be converted into work. Now, we arrive at the important part, which is we shall later visit. Now, listen carefully. This pertains to an isolated system. Specifically stated, the second law of thermodynamics states that entropy of an isolated system is left to a spontaneous evolution, cannot decrease as they are always, did I say that right? I should say isolated systems, as they always arrive at a state of thermodynamic equilibrium, whereas the entropy of a system and its surroundings account for an irreversibility of a natural process. So, entropy in an isolated system will always be continuous. Or it could be, or it could not exist at all. If there is no entropy, then in an isolated system, then it's not going to dissipate. And that's a significant thing, especially when we're looking at the universe being an isolated system. Now, there is a theoretical, though impractical, loophole, and this is where what I'm getting to here. In everyday reality, as we know it, this is impractical. It's known as the Cardinal theorem, and this is somewhat relevant to what we're getting at here. We will return to this later. The third law of thermodynamics, which states that entropy in a system approaches a constant value when its temperature approaches absolute zero. In other words, it's kind of like this concept that zero cannot be replaced. Think of it like if you understand integral calculus. You cannot get to an absolute zero, but you can approach it. And if quantity, and you cannot, if you look at an area under the curve, it cannot be precisely defined because it's going to be a series of calculations. It's going to be summation and it will be continuous. Has anyone found up to this very day the exact definition of pi? The answer is no. We know it starts at 3.14 and then the numbers continue on and on for eternity. It never ends. Well, this is how we can think of entropy. It will approach a constant zero but never achieve it. We can understand the term for practical purposes, yes. But the reality of the situation is no. Now, let us switch gears and talk about entropy. After all, this is a word I have used quite a bit in today's discussion. The first and second law of thermodynamics are all about entropy. Now, what is it? In simplest terms, entropy is the unavailability of a system's thermal energy for the conversion of conversion into mechanical work. Work in physics means something different than the way we use it in everyday conversation. Work being the ability of power to do certain things, to perform certain reactions, to transform things. This is work. And theoretically, and we're talking theoretically, the universe is doomed to heat death. What does heat death mean? Well, this is a grim subject that for many people, myself included, is kind of a disturbing concept, and that's that the universe itself will die. You might say that, look at it this way. The universe, at its beginning, and we don't know what triggered this, and there are all kinds of speculations. I won't get into them all right now, but in just one burst, we had the Big Bang. And it was just a colossal release of energy. From a very small particle, the universe exploded. And it exploded and expanded and went into plasma. Plasma became atoms. Atoms became matter. And we finally had the stars, the galaxies, and eventually our own Earth formed, and you know the rest of the story. But what is believed to happen here is that as the universe expands, its entropy will set in, and it's going to dissipate. As I said before, energy cannot be lost or it cannot be destroyed. So we're not talking about the destruction of anything energetic here. Just that these particles will become useless. Planets will shift out. Stars will explode. Or their stardust will keep going out until they lose their heat. They just become, as to paraphrase an expression, the universe will not end with or this would actually pertain to Earth, but it won't end with a bang, but a whimper. It's going to expand until there is no more heat. And as previously said, absolute zero will never happen, but it will be for all practical purposes zero. And nothing will be able to survive this. At least that's the theory. There are other theories, such as that of an oscillating universe, which I think is a little bit more optimistic. But we don't know. Maybe the universe will oscillate. We'll go back to that same particle, and the Big Bang will occur again. Maybe we're part of a metaverse. These are all questions for another day, but now this will be a process which will beat thermodynamic equilibrium. That is to say, when entropy can no longer be sustained. And thus work, in a physical sense, in the sense of physics, will need to be able to be performed. So in other words, at the end of the universe, the work will not be able to be done. Now there's some dispute, as I said before, regarding the heat death. Now we're coming to one of the greats here, Max Planck, German physicist. He stated that the entropy of the universe is a meaningless term because it admits no accurate definition. So he had a disagreeing opinion on the theory of a heat death. And as you might expect, this did get a lot of criticism from a number of sources. Some stated that there is too little, and this came from several sources. Um, there is too little of the universe to be understood to justify such a proposition. Now, as I should say, that this is the current paradigm, but throughout history, paradigms regarding physics, and science in general have shifted. Where is it that who among us right now believes that the sun revolves around the earth, or the universe revolves around the earth? Now, this is what was thought in the Middle Ages, where we don't live in the Middle Ages. But what's to say that in the future we're going to find that everything we know about the universe is wrong? Well, we're going to also look at physicist Walt Grandy, another interesting guy. He still lives. He's got some very interesting ideas. I urge you to check him out. In 2008, he wrote that the universe's entropy had not ever been in equilibrium with its constitutes in an entire existence. And he uses that as a way of refuting the idea of a thermal death of the universe. Another interesting guy here, Italian physicist Giovanni Gallavotti, who born in Italy. I believe he currently is in, I don't know if he's in U.S. or Canada. I believe he might be in Canada teaching. Anyway, he stated that within a stationary state, no notion of entropy exists. In my mind, the most compelling argument, I'm speaking for myself, in this argument against heat death, it comes from another physicist, Lee Smolin. Lee Smolin is an author of several books. You can find him online quite a bit. He believed that gravity is needed to keep the universe in equilibrium, and that when energy is removed, velocity increases. Instead of homogeneous equilibrium states, systems will instead be reconstructed into subsystems. Entropy will be transmitted from one subsystem to another, but its production will be zero. So the second law of thermodynamics will not be violated. Now that we have defined the isolated system, the laws of thermodynamics have a basic, and we have a basic understanding of it all. Let's look at human immortality. Now we're getting to some of the fun stuff here. I have lectured considerably about the subject of an afterlife in the past, but I think we need to examine this again in the context of thermodynamics. We're going to look at a few things here. We're going to look at, and a lot of this is stuff that some people will consider to be what is referred to as woo, which is a way of disparagingly looking at things that are not rational, or things with confirmation bias. I will agree that some of this is not scientifically based, but I think that there's always an element of truth in everything. You know, you might you might not believe something to be true. Maybe astrology is fake, but who am I to judge? I don't know. But maybe it's just because people are born a Leo and they know how Leos are supposed to behave or act, that they become what they see themselves as. So anyway, I digress. The yoga philosophy sees all three forces of energy in the world as an expression of consciousness. Now, this is going back to ancient Indian, read Hindu, and in some ways Buddhist philosophy here. Physical, psychic, and spiritual level. Consciousness is the one item which exists. There is only one God, but from where is the universe created? And there's a question mark there. Consciousness and energy are interconnected. Now, many people know about the self-help guru Wayne Dyer, who stated that there is an energy in the universe. You are the spiritual being having a human experience. This energy can be called God, Buddha, or anything else. Now, I find this to be an intriguing, how should I put it? An intriguing belief, an intriguing school of thought here, and one that I believe may have some validity here. We are separate from the forces of the universe, and in both a physical and in a how should I put it? In a philosophical line of thought, that this kind of conforms. It is a valid explanation of this. We separate from this force when we are born. We are conceived. We grow in the womb. We are born, and then as we grow in age, we acquire an ego. We acquire a persona. And at the time of our death, we return to that energy. The ego and the persona are lost. But since consciousness is a force, it is conceivable that consciousness is not lost. Now, Lao Tzu, the Chinese philosopher, think Taoism here, he stated that we are all part of the energy. String theory holds that matter and energy and space can all be related to energy. Kenneth Arnold states that consciousness is a type of energy. Kenneth Arnold is another physicist. I believe he's a chemist. He has lectures out there. You may want to check him out on YouTube. But conscious ontology separates the physical matter. Now, or can matter generate consciousness? Arnold says that it does not. Now, he stated this hypothetically, that the rhetorical question, can matter generate consciousness? And he says, he denied this, but he said that consciousness is a form of energy. Now, there's one term that kind of that many of us don't quite understand, and it's kind of it's not as difficult a concept as it sounds, but ontological, if you want to know what that means, it means pertaining to nature of being. Pertaining to you, pertaining to me. ontological math pertaining to our existence, to us, ontological physics, ontological science, you name it. That's what that word means. Anyway, energy is a higher form of consciousness. Conscious is to energy as energy is to matter. Consciousness is fundamental to the primary, and the energy is to the secondary. String theory, m equals ec squared, which is a variation of of Einstein's equation. That's territory. So one springs from the other. Consciousness to energy to the string theory. Consciousness condenses into energy, and then death. Now, death anomalies are not anomalies for that reason. So says Arnold. And consciousness then is eternal, always was, always will be. Physics cannot prove. Now he did make this statement when asked. He said, physics cannot prove that consciousness becomes energy. Consciousness directs energy. So does consciousness live beyond death? This is a question that I think is crucial here to this lecture. Now we're getting into an area that, as I said before, this is all what skeptics deny is real. They say this is not a rational belief. I myself think somewhat differently. It's one of those, well, who really knows? But I, as someone with a scientific background, I am skeptical on some matters. I don't have a lot of faith in things like tarot cards. I think they're fun to play with. It's like Ouija boards. Some people say Ouija boards are demonic or they bring in evil spirits. I don't think so. I think it's just more like it's a diversion, something that teenage kids like to play when they're alone and want to get spooked out, or things like that. But tarot cards, I previously mentioned astrology and the like, are not things that I have a focus on my attention. Now, maybe you believe differently. I'm not going to say that you're wrong. It's just not what I believe. You're free to believe what you want to believe. Hey, if you want to tell me that the Earth is 6,000 years old, or that the Earth was created in 6 days because the Bible says so, then I fully support your right to believe this. I don't have a literal view of the Bible. Maybe you do. I am Christian. I call myself a Christian now. Albeit more like a Christian Buddhist or a deist Christian, but I'm sort of like a universalist. I'm not a member of that particular faith, but that's what I think. Anyway, I don't fault people who play with these things, but that's okay with me. I do think now one thing I do think is possible. And you're going to find this all hokey, and maybe it even may damage my credibility saying this, but I think that ghosts and spirits just might be out there. This is mentioned in the Bible. It is mentioned in all holy books, whether they are Hindu, Buddhist, Chinese, traditional Chinese beliefs, traditional Asian beliefs, such as worship of ancestors, Taoism. They all believe in the existence of spirits, which are beings which walk the earth, things of an otherworldly nature. If you saw the movie The Shining. I didn't read the book, I confess. I really should have. I've been needing to do it for some time. But I'm aware of the book by Stephen King, but I did see the movie, and I remember one dialogue between Doc, who was the kid in the show, and the overseer of the Overlook Hotel, the guy who, well, they both had psychic abilities. And he explained, and the older man in the show explained to the kid that if you burn toast in a house, like in your kitchen, you may take the toast out. You may get rid of the toast, but that smell is going to be there. And that, as he explained, is the shining. That's how I see the spirits as being. So, are there ghosts or spirits out there? What about electronic voice phenomena? This is a very much, there's been a lot of claims that this was debunked. I'm not so sure. What about Akashic records? This is something I have studied in depth. I've read probably about 10 books, and I'm not exaggerating. I read about 10 books on this. I've taken a real interest in it because I believe I really wanted to tap into that knowledge. This is something that Einstein believed in, believe it or not. Einstein was a believer in a lot of esoteric knowledge. Shall I say, I would not even say that Akashic records are esoteric, because they're actually something that are available to anyone if you really are willing to learn about them. You don't have to be initiated into a particular order. I do have some suspicions about near-death experiences. Why? Because, well, I won't discuss it. That's another subject for another day. I think that there are a lot of scientific explanations why they occur. And I'm not going to get into them all, because that could take volumes. I could write an entire book on this about the pros and cons of near-death experiences. But maybe your experience has been different. So the question is, does consciousness survive death? Well, we could also look at past lives regressions. And here we're getting into the whole concept of reincarnation. Reincarnation, we think of it as something with the Hindus, but this is not just in dharmic religions. You may not know this, but in certain traditions, particularly like the Australian Aborigines, and I believe a number of other religious traditions among hunter-gatherer people, and in other unrelated spiritual modalities, reincarnation is a staple belief. I've heard from one source that this was even adopted by the early Christian church before the Council of Nicaea. I really need to do more research on that. Unfortunately, I didn't really have time to really look into that, but that's something I plan on doing in the future. But as far as, but there have been some studies with past lives regression. There have been children that could remember very accurately their past lives. Some even remember exactly who they were, and they could be pinpointed to exactly who they were. Is this all true? I don't know, but it's a very interesting story anyway. And we can spend hours talking about this also. But at this stage, I can't tell you everything I already found out. But it's something you can all find out easily if you look online. You could always look at just about any, use any web and search engine to find this. There are a lot of articles and videos surrounding survival of death. Um, but as far as what we're really out to talk about here are the laws of thermodynamics and the definition of an isolated system. Let's just summarize by saying that we concluded that uh, can we conclude that human consciousness is eternal? Um, it, I believe that it is very possible, and I believe very strongly. I don't believe in absolutes. I am not absolutely certain about anything. Uh, I believe in sophism in that I believe that the only thing we really know for certain is our own existence. Is any of this real? From my perspective, as far as I can see, this camera in front of me is real. The bookcase in back of me is real. My hand is real. But that's how I perceive it. Um, Color, after all, is not real. It's just how the human eye perceives different light waves and different light patterns. So that concludes today's topic, and I hope we all learned something. And until next time, stay curious.